So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, our slogan is we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problem. So today we focus on MIT 2024 Integration B Finals Lightning Round, problem number 2, and it's a fairly simple problem, which is the indefinite integral of open bracket x over x minus 1 close bracket to the power 4. Now, before I jump onto the solution, I'd like to thank our subscribers. Thank you so much for the support you continue to show us. We don't take your support for granted. It is your support that motivates us to come here time and again to share with you the solutions to our problem. Next, to our first-time visitors, what we do at Everyday Mathematics is we go about, we look at problems, we think we can solve them, we come back to you with the solutions that we think befit some of the problems that we propose to you. And to our repeating visitors who haven't subscribed to our channel, we do really ask you to consider subscribing to our channel. Your support would go a long way in helping us get the extra visibility we need. So on to the solution of this problem. So the first thing that I would do is just say let u be equal to x minus 1, because why? I don't really like having this extended formats in the denominator. So what then that results to is du dx is equals to 1, and therefore if you do go on with the substitution, you can replace dx with du if you replace x with u. And so the integral now becomes the integral of in place of x, since x is u plus 1, we have u plus 1 to the power 4, and the denominator x minus 1 is u to the power 4, and in place of dx we have du. Now what is u plus 1 to the power 4? We can use Pascal's triangle. 1, if it's this power is 1, we just go with 1, and if you have two items to the power 1, we have just 1 and 1, and then if you have a square, and then the quotients are 1, 2, and 1, and if we're talking about power 3 here, we have 1, 3, and 3, and 1, and if we're looking at 4, we have 1, 4, 6, 3, and 1, and this just comes from adding the successive numbers in the upper row. What we can now get from u plus 1 to the power 4 is, for the quotient 1 is u to the power 4, quotient 4 is 4 to the times u to the power 3 times 1 to the power 1, and since 1 to any power is 1, we'll remove the 1 component, we'll just not bother about that, and then 6 times u to the power 2, sorry, this is 4 here. I should have paid more attention. It's not working. My pen is not working. 4. Okay, this is 4u and then 1. Then we divide through by u to the power 4. That results to 1, 4 over u, 6 over u squared, 4 over u to the power 3, and 1 to u to the power 4. So going forward now, trying to integrate these independent terms independently. For 1, it's u, 4 over u is 4 log u, and 6 over u squared is minus 6 over u. And then for 4 over u to the power 3, we have minus 4 over 2 u squared. And then for 1 over u to the power 4, we have minus 1 over 3 u cubed. Now, since we can continue working with this, so that we have 2 here, simplify the numerators, and since we know that u is equals to x minus 1, we'll just substitute in where we see u with x minus 1, and this is what we get, plus obviously c, which is our integration constant. Now it's just a little bit uncool to have a constant here, another constant here, so we can bunch this constant with this c here, and so we have x plus 4 log x minus 1 minus 6 over x minus 1 minus 2 over x minus 1 squared minus 1 over 3 times x minus 1 cubed, and then plus the new integration constant. And this is the answer that was provided. It was a fairly simple problem. I hope you enjoyed our solution. Thank you very much. Until next time, à tout à l'heure, la prochaine fois.